Welcome back, and in this example, we're going to be working with the circle again. So let C be the curve, x of t is cosine t, y of t is sine t, and we're going to let t go between 0 and 2 pi. So part A, we're going to find dy dx. So remember, dy dx is just y prime over x prime. So y prime should be the derivative of sine t, should be cosine t, divided by the derivative of cosine t, which should be negative sine t. Okay, you could write this as negative cotangent t, but this is typically the way you want to write it. Okay, and typically the reason why you want to write it like this is for the next part of the problem. Okay, we're going to find all the horizontal and vertical tangents. Okay, so to find vertical tangents, remember this occurs when the denominator is 0. So dx dt is 0. So that means negative sine t is 0. So that means t should be 0, pi, and 2 pi. Okay, so maybe not 2 pi because we didn't include it here, but if we just tack it on there, then yes. So I guess not 2 pi. So those are our vertical tangents. And we have our horizontal tangents when dy dt is 0, because that would be the numerator. So we just multiply through by the denominator, and then so it happens when dy dt is 0, so this would be cosine t. And that means t equals pi over 2 and 3 pi over 2. Okay, so if we draw our circle oriented counterclockwise, you should notice we have two places where there are vertical tangent lines. Vertical tangent lines at t equals 0, right? So t is theta, so theta equals 0, and then theta equals pi. So those would be those. And then we're going to have our horizontal tangents at theta equals pi over 2 and theta equals 3 pi over 2. Okay, something it's also important to remember how to do is we can find the equation of a tangent line. Okay, so we can do something like this. We want to find the equation of the line tangent to the curve C when t is pi over 6. Okay, so we need to do a few things here. First, in order to find the equation of a line, we need a point and we need slope. And we have neither of those things right now. We have a t value. Okay, so we need point and we need slope. So point. Our point is just going to be the point cosine pi over 6, sine pi over 6, right? So that's plugging in our parameter into our curve, into our parametric equation for our curve. Cosine pi over 6 should be root 3 over 2. And cosine pi over 6, or sine pi over 6 should be a half. Okay, so let's, nope, not do that. Okay, then in order to find the slope, what we're going to do is we're going to plug in pi over 6 into our derivative, so dy dx, when t is pi over 6. So this is going to be equal to cosine pi over 6 divided by negative sine pi over 6. Cosine pi over 6 we said was root 3 over 2. And sine 3 pi over 6 should be negative 1/2 because we have the negative out over there. So this should be negative root 3. Okay, so if we go to our curve here, let's do this in green. So if we take theta equals pi over 6, it should be more or less here. And then we have the point root 3 over 2 1/2, which should be that point. And, oh, we didn't actually find the equation of the line yet, because we're going to take y minus our y coordinate is equal to our slope times x minus our x coordinate. Okay, so y should be negative root 3 x. That was interesting. There we go. Then we get what, plus 3 over 2 plus a half becomes plus, yeah, plus 3 over 2, yeah, okay, so plus 2. Plus 4 halves is plus 2. Okay, so if we draw this line here, should look something like this, and we can quickly verify that in fact it has negative slope, and if we've drawn this more or less correctly, at the up here this should be 2. Okay, and we'll come back with another fun thing from calculus that we can now do with parametric equations.